Hi, my name is Jonathan Knight. I'm a member of the Coherence development team. Welcome to this screencast about the Authorization and Audit framework that is a new feature of Coherence 12.2.1. In this presentation, we'll give an introduction to the new Authorization and Audit framework. We'll start with a quick overview of the new framework. We'll have a recap of some of the existing Coherence security features that are relevant to the new framework. We'll show how application code uses and configures authorization and audit, and finally we'll show a quick demonstration. The existing Coherence security framework is able to secure cluster membership, extend client connections, and there are some well-known patterns for how to do fine-grained cache access on an extend proxy. Coherence 12.2.1 has introduced an additional framework for authorization and audit. The primary feature being that authorization and audit now takes place on the storage-enabled member that actually owns the data being secured. This allows code executing on the storage member to know exactly who that security subject is that is accessing or mutating data, and allows much more powerful security functionality to be implemented. Because credentials are now passed down to the storage member, access to data can be secured and audited regardless of where the access originated from, whether it was from an extend client, storage disabled client, or another storage member. As already mentioned, previous versions of Coherence already provide frameworks to secure a cluster. Extend client applications implement an identity transformer, and the corresponding extend proxy requires an identity asserter to provide a subject containing the user's credentials. For application code that runs as a cluster member, Coherence can be configured to use a JAS login module as required, or the whole process can be wrapped in a JAS subject. The new framework for authorization and audit does not change any of these existing security functionality. There are no changes from previous versions of Coherence. However, your application is already configured to run securely. This now integrates into the new framework. New functionality has been added on the storage members to provide authorization and audit functionality for read and write operations against distributed caches. The authorization and audit framework is a pluggable API. Application code just needs to provide an implementation of the new Storage Access Authorizer interface, and then configure caches to use a particular Storage Access Authorizer implementation. The authorization and audit framework is purely server-side. If you already have systems that have existing clients secured using identity transformers or other methods to provide credentials to the server, then you can easily add authorization and audit with no client-side changes. Let's take a look at the Storage Authorizer interface. The Storage Access Authorizer interface is very simple. There are only 4 methods to implement. First, there's the check read method. This is called to authorize a read operation for a single key, for example in response to a GET call on a cache. The parameters to this method are the binary entry that is being accessed, the subject representing the identity of the client performing the operation, and a reason code specifying the reason for the read operation. The next method to implement is the check write method. This is to authorize a write operation on a single key. As with the check read method, the parameters are the entry that's being mutated, the subject representing the client, and a reason code for why the method is being called, for example in response to a put. The next method is called check read any. This is called in response to bulk operations that may impact multiple keys. One example would be, say, adding a map listener, where the client could be listening to multiple keys. The parameters for this method are the backing map context of the cache that's being accessed, the security subject, and again the reason code. The final method to implement is the check write any method. Again, this is for bulk operations on a cache that may impact multiple entries. One example would be, say, adding a trigger to a cache. The parameters to this are again the backing map context of the cache that's being accessed, the security subject, and a reason code. The Storage Access Authorizer interface also includes a useful reason toString method that converts a reason code to a human readable name. This might be useful if you are trying to log out audit messages with a reason code. And finally, there are all the constants representing the different reason codes. Now we've seen the API, we can look at how authorization and audit is configured. There are two places where authorization and audit is configured. The first is the operational configuration, commonly referred to as the overrides file. There is a new element called storage authorizers, which is a child of the existing cluster config element. The snippet of configuration shown here is actually taken from the standard operational configuration. Coherence provides one out-of-the-box storage authorizer with an ID of auditing. This particular implementation just logs all cache access to the Coherence log. The storage authorizers element contains the configuration for each storage authorizer. There can be as many storage authorizer elements as you require for your application. Each cache could, in theory, be configured to use a different storage authorizer. The storage authorizer element works the same way as many similar elements in the configuration, such as serializers, etc. You provide a class name or a class factory name and method name and any init parameters required. Each storage authorizer element has a unique ID attribute. This ID is then used in the cache configuration file to specify which storage authorizer is used by which cache. In the cache configuration file, a storage authorizer child element has been added to the backing map scheme element. This is only valid within a distributed scheme, so you cannot use a storage authorizer with, say, a replicated cache. The storage authorizer element's value corresponds to the ID of the storage authorizer defined in the operational config that we saw on the previous slide. This splitting of concerns between the two configuration files was an important design decision. For example, we have a cache configuration that specifies the name of the storage authorizer and is usually configured by, say, the application development team. Then the exact implementation of the storage authorizer that corresponds to that ID is controlled by the operational configuration. That could be provided by, say, an ops team at deployment and could be different for different environments such as test, UAT, production. As with a lot of new Coherence functionality, the new framework was designed in conjunction with customers who had requirements for stricter security. For some of these, it was important to split security implementation and configuration into an ops team and away from a development team. This is one reason why providing a two-part configuration was important. We can now see a quick demo of the new functionality. For the first part of the demo, we're going to run a couple of storage nodes with a very simple cache configuration file. All the caches are mapped to a single distributed scheme. This scheme is configured with the new storage authorizer element with a value of auditing. This will use the built-in storage access authorizer provided by Coherence that will just log all of the cache access. Okay, for the demo we'll start up two storage enabled members. These are just distributed cache servers configured with the cache configuration file we just saw. Now that they're running, I'm going to use an extend client to connect to the cluster. This is just a dummy client that's going to provide a dummy subject. So now we've connected using this normal Coherence console application. So let's create a cache. And now let's insert a value into it. So that's been added successfully. If we check the storage members logs, so here we can see this storage member has logged out the request for the put, telling us what the key was and the name of the principal that we logged in on the client. If we try and put another value, we can see this has gone to the second storage member. Again, we can see the key and who the principal was. If I do a get operation, so we've retrieved the value, go back to the first storage member, we can now see we have a log message for a read. So you can see that Coherence is logging on the actual storage members that own the data all of the access to the cache. Obviously, as well as audit, more important purpose of the storage authorizer is actually authorization. We can run a quick demo of the storage authorizer that will block write operations for non-admin users. Here is the storage access authorizer implementation we're going to use for the next part of the demo. As you can see, it's very simple. Each method we're going to just log the request, make sure that we don't have a null subject, and then for methods that perform mutations we're going to make sure that we have a subject with admin permissions. In our implementation, this is basically going to be a subject where a principal has a name containing the word admin. In order to use our demo storage authorizer, we need to add it to our overrides file. You can see here we've added a new storage authorizer and we've given it an ID of secure. And finally, in the cache configuration file, we change the storage authorizer value for our distributed scheme to secure, so that it uses the storage access authorizer we've just configured in our overrides file. So now we're going to start our two distributed cache servers again, using the second cache configuration using our demo secure storage access authorizer. Now those are both running. We'll start our client and we'll log on as an admin user. So let's create a cache and insert some values. And you can see that those have gone in successfully. If I now start the client again, and this time log on as a non-admin user, we should have read access to the cache. So we should be able to read the previous entries. So we can try getting one of the keys. And there we are, value 1 has been returned. So we have read access. But if we try updating the cache, here we can see Coherence has thrown an access denied exception from our storage access authorizer. So user Bob doesn't have write permissions to our caches. So there you can see the new authorization and audit framework is very simple to use, offers many more powerful scenarios for securing your application data. Being a pluggable API, you can easily integrate it into any existing authorization systems you might want to use. You can find more information on Coherence features and functionality in these links. Thank you for watching.